Hello and welcome to another video tutorial about FreeCAD. In this video tutorial we will model this bearing bracket shown here on the screen. We will use the part design workbench and therefore we will do more lessons in setting up sketches and constraining them and using the pad and pocket operations with the different available options. The version we use here is a 0.14 stable release on Windows 7 64-bit. Before we begin with today's lesson, we have to talk about something in 3D CAD which wasn't of importance in the first three lessons, but from now on it will be. We have to talk about shape refinement. What does that mean? Let's have a look at an example. I will create a new document, switch to the part module workbench, and insert a cube and a cylinder. Now if you take a look at these two objects, we already have here an overlapping volume. So if I highlight the two objects and do a Boolean union, so I will fuse the two parts, these lines could be removed because they are unnecessary. We have a common volume. To do this manually, you can highlight the body here in the tree view, and you can do here from the top menu, part, refine shape. See here, since I did a manual refinement of the shape, these lines were removed. The same with the down side of the object. Of course, there is also an option to do this automatically. Every time you do a union of parts to check if there is a refinement possible and when to do it. So if we go to Edit, Preferences, and we use the part design register, we will have here 3 tick boxes to automatically check model after Boolean operation, to automatically refine the model after Boolean operation, and to automatically refine the model after a sketch-based operation. I myself do tick all these 3 boxes and leave them ticked on for every lesson from now on. Of course, since this uses CPU performance, not every CPU is capable of doing this every time. If you have an older PC, in order to save CPU power, it would be an option to think about unticking these boxes and leave them unticked. But then you have to think about manual refinement of the shape. Okay, so I will choose Apply to make sure that the changes do take place. I choose OK. I will close all documents, create a new document, and now we are ready to begin our lesson for today. Okay, first I will change to the part design workbench, and there I will start with a sketch. The sketch orientations should be the XZ plane. I choose OK, and I choose the polyline tool. Okay, I will make sure that the polyline tool recognizes here the origin. Then I will continue with a vertical line. I will apply a horizontal line, and I will apply a vertical line. Please note that by pressing M, you will change the behavior of a polyline tool. You press M once more. You could continue like this. Pressing M once more, continue arcwise. or like this direction, or press M once more, like here, or pressing M once more to continue like we used to draw. By doing a right click, you will end the polyline tool. I will choose the polyline tool again. I will begin here. I will apply a vertical line, a horizontal line, and then a vertical line which ends directly on the x-axis, and then I will go back to the origin. I will end with a right click the polyline tool, and now we have over constraining, because if we choose this point to lie on the x-axis, and if we set a horizontal constraint, this is both the same information. So let's highlight this constraint here and press delete on the keyboard to delete it, or you can also highlight the constraint here, it is constraint 15, do a right click here and choose delete. These are your two options. Okay, next thing is to create an arc, to set the midpoint somewhere here, to catch up this point here, and to catch up this point here. We also create a circle by catching the center point here, and we draw another circle roughly here. So now we made a rough sketch, and we will begin to constrain it. A good strategy for constraining sketches is to first look at some of the obvious constraints, if they are already set, and if not, then to apply them. Obvious constraints would be vertical lines and horizontal lines, and even tangency or symmetry, or perpendicular, or something like that, or the same length, so equality would be also an obvious constraint. If we look at the sketch here, we could apply a tangency constraint here, and then we are done with the obvious geometrical constraints. So next step would be to highlight the line here to apply a vertical constraint of 5 millimeters. Here we will apply a vertical constraint of 10 millimeters. This we will choose to be 25 millimeters. This line we will choose to be of horizontal length 55 millimeters. Here we apply a horizontal constraint of 24 millimeters. So now we apply a radius here of 15 millimeters, and the inner circle will get a radius of 7 millimeters. So now we have only to constrain the last circle here, and then we will be finished with the first sketch. So first thing is that we could apply a horizontal dimension of 12 millimeters, and we could apply a vertical dimension of 10 millimeters. So as you have already done with the casino dice in the third lesson, you will also be able to use construction geometry to constrain the position of the center point of this circle. You could draw a line from this point to here set a horizontal constraint, and then you could apply to the center point in regard to this horizontal line symmetry. This would also this would automatically constrain the circle to be on the same vertical coordinates as this line, so with 10 millimeters, and in the middle of this distance, this would mean with 12 millimeters. Okay, so now we apply a radius of 3.5 millimeters, and we only have one dimension left, and this is the vertical distance here. We choose this to be 45 millimeters, and as you can see here, we have a fully constrained sketch. So now we close the sketch and we can continue with the next operation. Okay, the next thing we will do is select the sketch and pad it. We will give it a pad length of 50 millimeters and choose symmetric to plane. We choose OK. And if we choose axisymmetric view and fit all, we should have a figure like this. The next step will be to choose this face here and then to apply a sketch on the face. We will create a circle. We will ensure that the center point of the circle is lying on the x-axis. And then we will highlight the center point of the circle and the origin. And we will apply a horizontal constraint of 55 millimeters. If you did a constraint wrong and want to change this value, remember to double click on the constraint here, and then you can enter a new dimension of your liking. So the next thing is to constrain the radius. We will constrain the radius to be 25 millimeters. We will close the sketch and then we will pad the sketch. So if I press now the scroll wheel on my mouse and move the object a little bit around the x-axis to have a better view, you will see that the padding goes the wrong direction. Okay, so we have to choose reversed. And now we have to look at the possible options here. You can either pad a certain dimension, or you can either pad 2 dimensions, meaning let's say 50 millimeters in this direction and 10 millimeters in opposite direction. Or you can say to the last face you will meet on your extrusion path, or to the first face, or up to a certain face you will choose manually. So in this case we could switch to first. We click on OK, and if you have a look at the model here, it already did model refinement by removing this line here, and of course this line here on the downside face of the object. So now we have a model which looks like this. So the next operation would be a pocket operation. So I'm choosing this face here. I choose sketch. I choose the rectangle. And Here we go. I create the rectangle like this. When I choose these 2 points and the horizontal axis and apply symmetry. Okay, so the next thing would be to apply a horizontal dimension of 25 millimeters here. And then we will apply a horizontal dimension of 35 millimeters here and a vertical dimension of 36 millimeters here, and we're all set. We have a fully constrained sketch. We can close the sketch. We make sure that the sketch is highlighted, and when we pocket the sketch, not only a dimension, we say through all. And as you can see here, this is what we get as a result of the pocket operation. So the next pocket operation will take place on this face here. We will create a sketch. We will create a circle. We will make the center point of the circle to lie on the x-axis. We will have it an origin distance of 17 millimeters. And we will have it, let it have a radius of 7 millimeters. We close the sketch. We apply pocket through all. And here we go. So now we apply another pocket operation. We choose this face here. We open up the sketcher. We choose circle. We let the center point be an object of the x-axis. We choose the distance from the center point to the origin to be 55 millimeters. Okay, and we choose the radius to be 6,5 millimeters. We close the sketch, and the sketch is highlighted. We do pocket, we say through all. Here we go. So now we have the next pocket operation successfully completed. Okay, the next thing is that we want some sort of shoulder to have to be here. So I choose this face, apply sketch, and then I will create an edge linked to an external geometry. So I click on the icon here, and as you can see now, if I move the icon over certain elements, it will highlight them so they can be taken from one geometry to this sketch I have now created. So if, for example, I choose this edge here, then I have the edge now as part of my sketch for reference. So I can now choose to create a rectangle, and I can highlight this point here and say and give it a constraint that these 2 points are coincident, and I will also make this point here coincident with this point. I will then apply a vertical dimension to, no, I was wrong. I want to have a horizontal dimension. Now we are all set to be 10 millimeters here. And we have fully constrained sketch. I will close the sketch. I will pad the sketch to a length of 10 millimeters and click on OK. And now we have the next step made here. Let's switch back to axometric view and save it all. And we are ready to apply another pocket operation to this model. Okay, for doing that, I select this face. I select apply sketch, and then I will do one more circle. I will choose the center point to be part of the axis. I will choose this distance here to be 20 millimeters. I will choose the radius to be 10 millimeters. I will close the sketch. I will apply a pocket operation. And let's see if to first will exactly find this face as the end of a pocket operation. Okay, here we go. We save it all. And we only have to apply one final pocket operation to complete our model. So for the last pocket operation, I will choose this face here. I will apply a sketch to this face. I choose rectangle. I will click like this, so that this point is part of the vertical axis. Now I will choose 2 points and the horizontal axis and apply symmetry. I will have a vertical distance of 30 millimeters. Okay. And I will have here a distance of 3 millimeters. I say close. I apply pocket operation through all. And that's it. I've applied all operations and my model is complete. And with this, we have reached the end of today's lesson. Thanks for watching. I hope you have learned something and maybe see you in another video. Bye!